Welcome to a lesson on the equilateral triangles theorem. The goals are to define an equilateral triangle and also to prove the equilateral triangles theorem. An equilateral triangle is a triangle with three congruent sides. So if each side of the triangle has one hash mark, we know that the three sides are congruent. And we should recognize that every equilateral triangle is also an isosceles triangle. Remember, an isosceles triangle has at least two congruent sides. Now the equilateral triangles theorem tells us that all equilateral triangles are also equiangular. So if we have an equilateral triangle where we have three congruent sides, then this theorem tells us that the angles are also congruent. Let's prove this theorem. Here we're given that AB is equal to AC, which is equal to BC. We want to prove that angle A is congruent to angle B, which is also congruent to angle C. So if all the sides have the same length, or it's an equilateral triangle, the triangle would also be equiangular. Let's start by stating the given. Now if all of these have the same length, then they would also be congruent. Let's go ahead and state that. Side AB would be congruent to side AC. Side AB would also be congruent to side BC. And side AC is congruent to side BC. This is true by the definition of congruent segments. If these segments or sides have the same length, then they're also congruent. So if all of these sides are congruent, then triangle ABC would be an equilateral triangle. And this is by definition of equilateral triangles. Now, as we said just a minute ago, every equilateral triangle is also an isosceles triangle. And we just proved the isosceles triangle theorem that tells us if two sides of a triangle are congruent, then the opposite angles are congruent. So if side AB is congruent to side AC, notice angle C is opposite side AB, and angle B is opposite side AC. We know that angle C must be congruent to angle B. It's also true that if side AB is congruent to side BC, angle C is congruent to angle A. And if side AC is congruent to side BC, we know that angle B would be congruent to angle A. Notice the letter of the angle is the vertex that's not an endpoint of the side. And the reason for this is the isosceles triangle theorem, which we proved in the previous video. Which is what we were trying to prove. But let's go ahead and just state that triangle ABC is equiangular. And this is by definition of an equiangular triangle. And I think we'll go ahead and stop there. I hope you found this helpful.